Let's talk about volume of cones and pyramids. So first, let's get an idea of what is a pyramid. So a prism is where we have a base and we just protrude that base up. So the prism in this picture is that cube shape we've got going on here, this blue cube. And so basically it started with a square base. This is kind of our square base, and then it just protrudes up. Now, a pyramid has whatever base we want, any polygon here. Here we happen to have a square, and the pyramid just follows that up to a vertex or that point at the top. And so it's not a uniform shape. So for prisms, I like to think of a loaf of bread where each slice is the same. So if I cut this horizontally, each slice will be the same. However, for the pyramid, the slices at the bottom will be bigger squares, and the slices as we get towards the top will be smaller and smaller squares. So that's what a pyramid is. Now, to find the volume of pyramid and cones, there's a beautiful relationship where whatever the size of the prism is, or whatever prism this cone can or pyramid can fit inside of, it takes up a third of the space when the pyramid has the same base as the prism and the same height as the prism. It's 1/3 of the space. So let's look at this. I just want to convince you that this pyramid inside of this uh, rectangular prism or like rectangular cube is the same height, and it does have the same base. So our pyramid and prism have the same base and height. Now, just be aware of these volumes being calculated. So this is calculating the volume of this prism and then the volume of that pyramid. They are being rounded, so there might be a little rounding error in here. But what we'll notice is wherever I put this, if I take these numbers, here's an easy one to work with. 120 for the volume, so cubic, whatever units we're using. Let's say we were in inches, 120 cubic inches. Notice that the volume of the pyramid is 1/3 of that. Just take the volume of the prism and divide it by 3, and you get the volume of the pyramid. So if we know how to find the volume of a prism, which is just the area of the base times the height, and we just take 1/3 of that answer, there's the volume of our pyramid. Let's choose another, let's see, a 90 would be a nice number to work with. And there you go, 90 divided by 3, 30. So no matter what size pyramid I make, the prism that it fits inside of with the same base and height will be triple its size. So that prism's triple its size, or you could think of it as the pyramid's 1/3 of the volume of the other. Let's choose another. 60 is a nice number that's divisible by 3, and there you go, 20 for the volume of the pyramid. Now this is true, like I said, true for any prism you want to put at the base. But it doesn't even have, or not any prism, any polygon you put at the base. Now it doesn't have to be a polygon. It can be a circle to make a cone. And it will be the same story. So let's do 180 for the volume of the cylinder. So a cylinder is a circular prism. Now the cone that fits inside of it with the same base and same height is 1/3 the area. So if I have the volume, or 1/3 the volume, if I have a volume of 180 for this cylinder, the volume of my cone inside is 60, 180 divided by 3. There's a story I love to tell about my son and I. We were at a Halloween event at a open space park, and they had a jar of candy. You've probably done this at some point in your life where you guess the amount of candy in the jar. And this jar was kind of shaped like a wine bottle, but in the form of a cone. And then it had a neck at the top. And so we actually used the fact that since it was a cone shape, that it'd be 1/3 the size of a cylinder. So what we did, and they were candy corns inside, is we basically took the bottle, flipped it to look at the bottom, and saw about how many uh, candy corns were in what was kind of a first layer of the base of the jar. And then we counted how many layers there would be. And so if it were a cylinder, it'd just be, okay, let's say there were 10 candy corns down there. And then let's say there were like 20 layers, then we would have or let's make this even easier, 10 at the bottom, and let's say there was like 30 layers of candy corns about. I mean, there's not perfect layers, but we estimated. Then 10 times 30 would give us 300 candies. Now it's a cone shape though, so we just took 1/3 of that. So we would have said 100 candies, right? And we ended up winning. We won the little competition and got a free parks pass for the year. So that was it's kind of fun to show my son, hey, look, math paid off directly. So pyramids and cones take up 1/3 of the prism they fit inside of that shares the same base and height. Let's do a couple examples. We'll do one for a square pyramid and one for a cone. So let's start with this square pyramid. All right, let's give some context to this problem. Let's say that this pyramid was 12 inches by 12 inches. And let's say it had this slant height, measured that, and it was about 10 inches. All right. So that slant height is not the height of this pyramid, so that makes this a little trickier. So let's actually find the height or the altitude. So the height or the altitude, I could basically make this triangle, it goes down to the center of that base. There we go. So you can see this triangle. I'm going to pull that triangle out. It sits at a 90-degree angle. And the base here is just half of the distance of that square base. So not 12 inches, but half of that, 6 inches. And then I know this slant length just matches that part, that's 10 inches. Right. And so I'd be wondering what that missing side is. Using Pythagorean theorem or recognizing that this is a Pythagorean triple, could also go that route, but let's use a Pythagorean theorem. We'd have 6 squared plus b squared equals 10 squared. So a squared plus b squared equals c squared. All right, so 6 squared is 36 plus b squared equals 10 squared is 100. Give ourselves a little room here. And subtract the 36. B squared equals, let's see, what would that be? 4 up to 40, and then 60, 64. Square root of both sides. B equals square root of 64 is 8. So B equals 8 inches. Now we know the height. So from there, we can now calculate the volume of this pyramid. So the volume is just 1/3 of the prism it sits inside of. And the volume of a prism is the area of the base. So in this case, we're a square, which is a special type of rectangle, but that'd just be length times width, and then times the height for the prism. And then we're just 1/3 of that. So the volume is 1/3, length is 12 inches for the width, and a height of 8 inches. Right. So let's see, 12 divided by 3, that first part, 4 times 12 times 8. And then that would be coming out to, punch that on a calculator, 384 cubic inches. We're volume, we're a third dimension, so cubic inches. Where did that cube come from? All of these had inches. So they're units, and we multiply them. Inches times inches times inches, inches cubed. All right, so just a third of the prism it fits in. All right, let's take a look at this cone. And let's give some context to this problem. So let's say we had a diameter of 12 feet. And let's say we were just given the height. So instead of that slant height, we'll make it a little easier on this one. And we'll say we were measured it a height of 7 feet. Or that height you can label there, whichever spot makes more sense for you. All right, so now the volume is just 1/3 of the prism it fits in. In this case, a circular prism, or we could call it a cylinder, is the volume of the base, pi r squared, times the height. So volume equals 1/3 pi. Our radius is half of the diameter, so 6 inches squared, times the height of, not inches, we're in feet, squared, times the height of 7 feet. All right, so volume equals 1/3 pi. 6 squared is 36, times that 7. All right, to simplify, I'm going to divide that 36 into 3. So what does that give us? 12 pi times the 7. And we have 12 times 7 will give us 84 pi. And that was feet cubed. So we could stop there if we want an exact answer, or we could punch out 84 times pi on the calculator and get an approximate, which comes out to 263.9 cubic feet. There we go. The cone is just 1/3 of the cylinder it fits in. So there you have it, the volume of cones and pyramids.